Hello, welcome from my side. I don't see many of you, but the room is pretty full. That's awesome. My name is Andreas Lippold. I'm from Esri. Maybe a couple words to myself. A long time ago, I studied geography, so I'm a geographer. And actually, my first job coming out of university was teaching ArcGIS maps to people. Soon after that, I went up to the north, to the Berlin area, to enter a company that was creating 3D models. Right? The company was called 3D Geo, so this was my first connection to 3D. So what we did is bringing all this data together and creating those nice representations of cities. So the city of Berlin, for example, has a so-called business location center where they present their whole city in full 3D. Underlaying is a GIS that gives the data for investors to search for a certain area. Soon after, we got acquired by Autodesk, and since then I was with Autodesk. And we invented or reinvented the tool which got acquired. And this tool is now becoming the tool called InfraWorks. I don't know if you know this, but this is, so to say, my baby. And since then I'm with 3D and also sticking to GIS and the AEC community. Since 2 years now, I'm with Esri. I got hired for being a product manager, looking after initiatives, not a product. So looking after 3D, AEC, smart cities, digital twins across Europe. Things changed within Esri, and suddenly I'm the 3D PM lead, leading a team of PMs, product managers, looking after 3D capabilities across ArcGIS, which is pretty amazing, at least for me and also probably for Esri, because Esri is a company sitting in Redlands, and they have this huge campus. But throughout Corona, it opened up, so we have many more people, employees working for Esri in and across Europe, which is actually pretty cool. And this helps us to formulate requirements that are not seen on the American continent, right? Especially around 3D, digital twins, open standards, and Europe is pretty advanced in this. And that's why I'm so happy to be here with you today. So we have a couple of minutes to fill. Let's get started. So maybe a couple of words to our vision and what we do and why we are doing things. And I would like to talk about a couple of things and then slowly tie into the digital twin topic, which I really like to talk about. And tomorrow we will have a more deep dive session on the topic of 3D and digital twins. So we may have a more interactive session to talk about these things. So in this case, Esri is committed to our mission of serving and supporting our users. And we are also working hard to advance the GIS tools and collaborate with you guys, right? So this is important to us to actually talk to you, to address the challenges we are facing together. And we are taking this notion of being engineering and science focused very seriously. And mapping and the geographic approach, how Jack is talking about it, unifies our technologies, science, and design thinking into a common vision. And, our world is a complex and highly interdependent ecosystem. Not just the natural world, but also the human world, or let's say maybe especially the human world. And many aspects of it are very fragile. So it's also rich in biodiversity. It's also not so well known and even less understood. The world that we are living in is changing rapidly, increasingly dominated by the human footprint, right? So we have so many activities going on and interacting with, our planet. And this is challenging for the whole world. So issues like human-induced climate change and overpopulation, congested cities and pollution. And sometimes careless development is setting in motion of a whole series of conflicts and instabilities. And we see this in the news every day. Steep declines in biodiversity, wildfires, flood. And these are signals or indicators about what's going on. We don't actually understand entirely what's going on. And that is actually the challenging thing, the sustainability of our planet. And actually, it's really threatening the future, right? And the central problem of all of this, and I think this has been always the case, and GIS is stepping into it, right, is not just any one of those issues, but it's a lack of understanding the issues as well as their interrelationships, and our inability to or failure to collaborate and work on them, right? So making sure people understand those problems. And many people have different points of views, different heritages, different ways of thinking, right? And everybody understands problems a bit differently. And a language, technology can change that or can help to provide at least a similar understanding of the problems. So we can share across different cultures and discuss, on the back of the problem and not discuss of the back of our cultures. So GIS, mapping and the geographic approach are powerful means to create understanding and to explore different alternatives, find solution and reach agreement. Mapping common ground, like Jack pointed out last year, you see a foundation for positive action and create agreed upon understanding. And we've been calling this the geographic approach as a way of thinking and a way of problem solving, being it all together. The geographic approach to education, to planning, to business, to energy generation, all of these various themes of work that we as a GIS professionals do are basically the geographic approach. And it's interesting because it's data-driven, it's science-based, right? It's not magic, it's not storytelling in a way like our grandfathers did. It's also very understandable through mapping, which is the underlying language. This is the theme for going forward, providing a framework for the world to better understand and apply that knowledge. So as I said, mapping is interesting because it's the fundamental language, right? So we create maps to show stuff to people, to have a common ground to discuss, right? It's like written language, mathematics or music, right? So mapping has been an instrument for these activities for thousands of years. And we can see that these historic remnants of mapping were instrumental for progress in civilization. Mapping used for navigation, discovery, land organizations. Today, the technology for mapping is rapidly advancing, and it is having a major effect on the way civilization will evolve. And GIS itself is a process and a framework for facilitating this geographic approach, getting all the data, visualizing it, analyzing it, and planning on top of it, designing strategic thinking and acting on it, making predictions, understanding the interrelationships between things, how they work together. And that's where the system of GIS comes in as a system for mapping, sharing, applying geographic information. And by looking deeper into how data sources get integrated and accessed, you will certainly see arguments for ArcGIS being a foundation for a term like living digital twins, and I come to that in a second. So everything is there in the GIS system. And what we do since the beginning is we are trying to abstract our world. We do create depictions of the world in 2D and 3D. Maybe then later on in 4D, 5D, whatever comes next. We create replicas of our natural and built environment in order to understand, to analyze. We add smartness to them using IoT and sensors, and to predict, to make better decisions. May it be sustainable, important, or economically, or even socially. And when you think about GIS abstracting our world, at least for me, because I'm one of the older ones now. Thinking about GIS, we think still about 2D, about maps, right? How you create maps and how you show different scenarios of our world. But when you think about the technology today, what we can reach, then, it's evolving. So what you see here on this little video, you see the vector data, polygons on top of an orthophoto, right? This is pretty cool, right? Now, with the help of technology, creating meshes out of it, highly detailed meshes, which itself is a stupid picture, more or less, right? But combining this information into one scene gives you a totally different impression of the thing you want to discuss, right? You can clearly communicate your information to people. So the third dimension gives a much more complex understanding of the complexity of the problems. One more time. Another thing is like using GIS, also using the 2D data, but using the 2D data and just adding a set value to it. You don't even need to create 3D data, but using the set value, you can easily create those kind of floor plans and get your 2D information elevated to create those depictions of the world for another aspect to look at in the real estate management, for example. Stuff like this, 2D information on the left-hand side, right? But new technologies make it happen that this scenario on the left-hand side is more visually appealing, is more immersive, people can understand. And if you think about the problems today, they are very complex. They have been complex in earlier years as well. But now we have to act more in a timely manner on it, right? And more people are involved in decision-making, not only the professionals or domain experts. So we need to bring in people that may not be familiar with what you see on the left-hand side, but they are familiar and they can recognize what they see on the right-hand side. Even, still the 2D makes sense for many of the use cases. So I'm not saying that 3D is the new thing that we all should use, but in conjunction with 2D and 3D and 4D, this whole ecosystem of ArcGIS has a huge potential to serve many of our challenges we have today. Another nice example, right? You have the mesh as a context. This is a stupid thing. This is a picture of the Earth, right? Jack calls it a 3D picture of the Earth. But you can use it, everyone understands it, and then you can do your planning. In this case, it's ArcGIS Urban, right? Connected to this surrounding. You can go into the mesh, flatten it out, so you can actually start sketching in it, right? And now suddenly people understand how it will be looking, right? How high are the buildings, what is their extent, what is their usage, in context of what's already there. And last but not least, we call it indoor GIS, right? We receive more and more information about the inside of buildings, especially through the connection of BIM and GIS. So this highly detailed models that come out of the BIM process, we can now import and bring into our GIS system to do operation and maintenance, asset tracking, indoor navigation. All these things are interesting things that might be new use cases for using a GIS for. And GIS professionals like you are already addressing all these great challenges we are having today. You are mapping all these factors, creating understanding and facilitating collaboration in all these various areas. And it happens all at scale, right? We can do it in... I'm here. Cool. And it happens at all scales, as I showed you in the little examples here, right? From a building, footprint scale up to a nation, country, world, whatever it is. And this is the huge benefit of what we can do within GIS. I'm coming from Autodesk, and we have this little universe of looking at a bridge. Maybe the longest we had is a 200-kilometer stretch of rail that needs to be created, but then you only look at the rail stretch, all right? And the rest is more or less not inside of what we are looking at. So when we look at maps, right, and I mentioned this in the beginning, when I think of maps, I think of what you see on the upper left corner, right? This is a map for me. And at Esri, we are talking about maps. We have a map viewer. And since we introduced 3D, we are talking about scenes, right? And we have a scene viewer, which is kind of odd. Maybe we should change that. But maps in general are evolving into 3D. You see more pictures on 3D. And when you have seen other conferences of Esri, like FedGIS or Dev Summit, more and more images of 3D appear on those screens. And maps or scenes, I still call them maps, 3D maps, have enabled us to shape land use decisions and plan the future of our societies. Also, we use maps to help us understand climate change and its effect on agriculture. Maps tell us how we depend on nature, administer land, and how we can transition to a more renewable future. And we have seen a couple of those examples in the presentation from Linus. Maps are used in engineering and public works, adding spatial context to projects. Right? This was what I'm talking about when we talk about an AEC project. Adding context. Where is this thing being built? What is the effect on its surrounding? And again, more and more 3D pops up. Actually, when I worked at Autodesk, we created this tool, what I mentioned before, and what we did is just sketching roadways. And it was interesting because when you talk to those people and you think about a 2D plan and you lay it on top of a table and you have 10 people sitting around it, and you would open each head, right, like in a comic, and then there's a picture coming out, you would most likely see 10 different pictures of what people saw in this 2D map, right? And that's why 3D is so important to limit the misunderstanding. Maps are used to keep us safe and, when necessary, help us to respond and recover from disasters. And also maps allow people with different backgrounds and expertise to understand who we are and support healthy communities. And maps are used across transportation and utilities to deliver services that we all rely on every day. And this is actually the interesting thing for us at Esri, to look at how we can incorporate this kind of information into our GIS system in this level of detail, looking how we can connect to the BIM resources and use them and create workflows that are helpful to solve problems. Yeah, and the technology is advancing rapidly, and it's helping us in this so-called endeavor. And it's advancing in analytics, in visualization, in storytelling, and also in integration of remote sensing, AI, artificial intelligence, machine learning, and so much more. Right? When you think about the GIS, which we had since years, all these cool things happening right now. Real-time imagery, AI, analytics, report and storytelling, 3D visualization. This all helps to understand more of our natural and built environment. It helps us to communicate, and it helps us to share information and make decisions based on a well-informed model which we look at. And geospatial infrastructure is growing, and it's more and more important for many people, and GIS professionals, not even GIS professionals, but for many people who are working with data and want to understand what it means for them, right? We have millions of users sharing millions of data sets, right? So the system, ArcGIS system, has a huge reach out, and many people even consume this stuff without knowing what's behind it, right? GIS, the term GIS is for many people not, how you say, grabbable, so they don't understand really what GIS is, but when they look at the map or a 3D map, and they're using it every day, they certainly can deal with it, they can work with it, they can enter and, that gives them information. They don't care about GIS. And then we have the portals. This is the key aspect of our geospatial infrastructure. It brings together available content and the work being done by GIS professionals in different fields to support key initiatives in various missions, in various mission areas. It enables the dynamic integration of information, facilitating collaboration, and transforming organizations, right? And I think it has been mentioned before, this connected system, more and more people, have their system, but we need to connect repositories, we need to connect data silos. And I think this is a huge step forward in connecting information. And GIS professionals have important responsibilities in facilitating this creation of common ground. And that means seeing what's needed and wanted, supporting community engagement, bringing together and connecting data and science to the decision makers and decision making, right? It involves a holistic approach, and this geographic approach notion considering all the factors. And also a subject that we need to talk about is maintaining public trust. And GIS professionals have the responsibility here too, in the data, in the maps that you make, and in the engagement that you are supporting. And the process of listening and understanding and resolving conflicts and creating solutions. And this is unique and powerful. And you and the work that you do and how you do it is really essential for pulling this whole thing off. Now let's take a look brief and an overview of our work at Esri. I don't want to go too deep into stuff because Vitas is showcasing some of the good work later on. So let's have a look at the ArcGIS vision. We see ArcGIS as a complete system for geospatial analysis and mapping, and also spatial analysis in support of the core GIS professionals. ArcGIS is also for multiple different communities, mapping and location services, for analytics, for imagery and remote sensing, and for developers. There's a huge ecosystem for developers. So you can connect to it and build your own applications, modify and customize your applications and workflows. And I'm sure we can do much more to help developers to create even better things that we cannot deliver. We are building ArcGIS to be open and interoperable. We deliver it to you as software, SaaS, and PaaS. And this is enabling personal productivity for individuals, for teams, and for the entire enterprise. So ArcGIS is implemented and deployed in different patterns or different user experiences, as I just mentioned. Many have been using the desktop for years, if not decades, right? It was the first thing. They've been able to access more and more data using servers, leveraging the cloud, portal, and its underlying geospatial infrastructure. You are now able to push that information out to new devices or to web applications, leveraging web services. And I know we have a lot of tools, and sometimes it's kind of tricky to find the right tool. But it's amazing what you can already do with all this underlying data in this kind of ecosystem. Yeah, one of the three foundational products is ArcGIS Pro, right? Is designed to be, connected to ArcGIS Online and Enterprise. You use the power of web services, both in consumption of and the publishing of new web services and layers. You can do all the analytics, you can bring data together. I won't dive too much into detail, but this is our software desktop offering, and Vitas will go into details after lunch for this. I just want to highlight this as a key component of our ArcGIS system. This is actually the base, the backbone of our ArcGIS system, where you start, where you bring in your data, and where you populate all your data for sharing, analysis, visualization, and more. The second foundational product is ArcGIS Online, right? Esri's SaaS offering for mapping, analysis, and collaboration, right? This helps us to share information across the web, access information across the web, invite people across the web, so you can collaboratively work together. Same thing, but only on the enterprise level, right? ArcGIS Enterprise, this is truly a GIS infrastructure for your organization, right? So you are not online and visible to everyone, but it's for your own organization, for your enterprise. It reaches from data management all the way down to advanced spatial analytics, to sharing and collaboration. And when we look at the ArcGIS system, it has three main core areas of focuses. One is the system of record keeping, like the cadastre or the wires or the pipes or the trees, right? This is the foundational thing within Esri. And out of this, we have the system of insights for analytics, very powerful spatial analysis tools. And finally, it's a system of engaging with people through maps and apps. But the baseline is the system of record. And if you think of a GIS system where you combine this information, and then you create maps which you show and share with people, right? You print out maps and you share with people. You do the analytics beforehand, so you can actually create those maps nicely and colorful and describe the certain circumstances. This is what we have been doing since years. But again, if you go back and see what we can do today, then it might look a bit different, right? Think about ArcGIS, what it can bring to the table using technologies. In this case, it's the use of game engines. It's the city of Gothenburg, and they created this kind of digital twin. You do all this analysis, right? And you produce this nice visualizations or interactive model with the help of game engines. You can interact, engage with people, right? In earlier times, we had maps. Now you have this interactive way of interacting with people instead of having a static map. And it's dynamic, it's adjusting, right? It gives you feedback from the field because we have the sensors. You can do the analytics, and you can show the results of the analytics very impressively. I know some of you may, how you say, turn your eyes and say, hey, yeah, this is nice, but this is what we can do today. And we should work on this with the help of ArcGIS to be the foundation of what we saw on screen, a digital twin, a metaverse, whatever comes next. And we have the power to do so. So as an enterprise system, ArcGIS supports many interconnected workflows to enable collaboration. Remember maybe the term which I mentioned in the beginning, the lack of understanding or failure to collaborate, right? This is what we are addressing with this kind of ecosystem. This is the big aim for us, to help with collaboration based on the system of record, providing tools that deliver information to the right, in the right way to the right people to understand. And then we have many, many tools. On the left-hand side, you see the powerful desktop apps, right? Pro in the middle, which is our, backbone, as I said already. And then you have many, many things sitting on top of it. We also have other desktop tools, City Engine, for example, to create 3D content, which is pretty powerful. You can create procedural content, which you can use across your ArcGIS system. And then you have this massive mobile deployments, field operations, work management, tracking, data collection, all these apps which are out there, right, which you can use in the field, offline, online. So there's a lot of stuff you can use. And for me, as I'm like the 3D guy, I would like to, concentrate on this common ground, which is the geospatial infrastructure, the system of record that fuels all those different needs of people accessing the data, contributing to the data, working with the data. And then we have all these web apps, right? We saw a couple of things already, like the dashboards is a very nice thing to highlight what's going on, And we are also working towards making this more and more a 3D kind of thing, right? We are not there yet, but in many cases, a 3D replication or representation in those kind of apps is very helpful, and people are asking for it already. And then when we look at the data that we can integrate and manage in ArcGIS, it's interesting when you look at this screen here, you see a lot of cool things which we haven't had before, or which we had before, but we had no solution. Think about like the unstructured data, right? Now we have knowledge graph and such cool technology that can combine and link data sets so we can actually get use of it. Multidimensional data, voxels, is a very nice invention to show discrete or indiscrete data in space. For example, you have sublayers, underground layers, soil layers. You have different ocean temperatures, how they behave on different levels. Or, for example, inner city temperatures, right? They are not only on one level. You have different levels of temperatures within the city. Noise pollution. This is very helpful to display this in 3D and analyze it and view it. Real-time information, right? Connecting to the sensors out there, which we now have, to understand how this thing is moving, how this thing is behaving. And all of these data sets bring value to the table, and we can use them in GIS. And ArcGIS is advancing rapidly, and these are the things behind the data, right? These are the technologies, the workflows that we are implementing to make more and better and precise decisions based on data. And these advancements are also being driven by integrating many of the new IT technologies that you see on screen here that are emerging: cloud, AI, machine learning, security, and mobile environments. And this is pretty challenging because customers always come to us, hey, we have this new tool and we have this new data set. Hey, can we? Yes, sure, but let's talk about it first and then see how we can integrate it. One thing I would like to chime in here is when you talk about technology and data, is the improved integration of CAD and BIM, or how we say, like the, working together on the GIS and the BIM side. And you saw this probably in the video in the beginning. We have this partnership with Autodesk, which for us is a huge, let's say, learning step. And everyone, I think, in the room here agrees that BIM and GIS, connecting BIM and GIS is a huge benefit. But no one really knows exactly what this benefit may be, right? So we started with Autodesk to have this partnership and working on a couple of initiatives to bring these things together. On the left-hand side, you see access CAD and BIM data from ArcGIS. So in Pro, you can actually import Revit, you can import IFC, and start working and analyzing with them. In the middle, you see the Autodesk apps, Civil, Map, 3D, InfraWorks, that have, the ability to connect to enterprise and online, to actually create the context for their design and construction projects. And then last but not least, we have a tool that is called GeoBIM, which is an online tool which is built on Experience Builder, that is using the online platform to look into two repositories. One is ArcGIS Online on the left-hand side, and on the right-hand side, it's ArcGIS Autodesk Construction Cloud. And the nice thing about it is you can have a representation in online, and once you click on it, you will actually see the detailed information right in the Forge system of the Autodesk world. That may help to communicate issues and face different challenges on a project management level. And then one thing I would like to highlight is that ArcGIS users are increasingly leveraging the cloud. And that's something which within Esri is pretty interesting, because we have so many years focused on the desktop solutions. But more and more of you guys and other customers are leveraging the cloud. They want to be cloud-based. They want to communicate across the cloud. And therefore, we are diving into this whole topic and creating more and more workflows. For example, we have the scene viewer, right? The scene viewer, as the name calls it out, it's a viewer. We can view the 3D content across the web in ArcGIS Online and Enterprise. But it's not a viewer anymore. People want to do more, right? They want to access real GIS functionality in the web. So this is what you would like to do, and this is what we are focusing on, to see how we can, bring GIS to the web in order to fuel those digital twins which you saw earlier. And then ArcGIS is open and interoperable. I know some of you may say, maybe, maybe not. We have a lot of extensions. We have a lot of FME tools that provide access to open standards and data, although we are not that good in connecting to open standards. And I mentioned in the beginning that I'm here and working out of Europe. And in Europe, we have many, many standards, and organizations and people within Europe are looking after those standards, and they would like to apply to those standards. We have, on the one side, maybe one standard is CityGML for the citywide operation, and then we have the BIM standards for AEC projects. In many countries, this is already standardized, and people need to deliver their data in those formats. But talking to my peers in Redlands, none of those is very important so far. Maybe the IFC stuff, but the CityGML stuff and others is not so important. So we are talking to customers over here, and many, many people think about their digital twin, and then they realize, oh, hey, I have 3D data, can I use it? And we say, yes, but, and so we would like to help them and make this more open. And open does not mean only reading those kind of data, but also connecting to different repositories other people may have. And this is their single source of truth, and we don't want to replicate the data in ArcGIS in order to do so. So creating this connected environment and be more open and flexible in terms of connecting to this data, so that our customers can use their data in ArcGIS ecosystem to provide a twin at the end of the day. Yeah, ArcGIS is a content sharing platform. It has been mentioned already today. So it's enabling you, to share all of your data securely to others and users through, they can search and discover all this content. It enables public sharing, where we are seeing millions of users start to gather together around maps and data in public collaborative environments. As well as ArcGIS includes ready-to-use content. We have seen this slide already. It's pretty interesting because this is a huge resource for customers to get started, especially in the 3D space. I know that we don't have as much 3D content in the Living Atlas, but we just released the OSM 3D base map for trees and buildings, and this is the first start so that people can get connected to 3D easily instead of sitting and opening the ArcGIS system and don't know where and how to get 3D data from, right? So this is very important for the whole ecosystem. And I know that distributors are also creating, countrywide informations for you to use in those different areas, which is pretty helpful. All right. My last slide in this series is the ArcGIS innovation and trends. I brought this up because you can see a couple of things here. Mapping and visualization, right, still occurs. We have seen a lot of stuff which relates to 3D. Spatial analytics, AI, machine learning, and big data has huge effect on how we deal with data, how we manage data, how we extract information out of it. Imagery and remote sensing is very, very useful to create depictions of the world from various devices, satellite, airplane, drones, even mobile phones, right? Comprehensive 3D GIS system. So this is where I'm coming from, right? We want to make the 3D piece in ArcGIS an integrated piece. I joined Esri in a couple of days, it's 2 years. And when I joined, 3D is still, and it is still, something we need to argue. Why do we have this? Esri is a 2D dinosaur. It is. And it's good. But now we need to think about 3D workflows. How can we enhance those things in ArcGIS? Because we have everything there. We just need to handle 3D nicely. And 3D is different from 2D, right? We cannot apply 2D patterns to 3D workflows. Data management, field operations, right? Take it into the field, and real-time visualization and analytics. So this relates to connecting the outside world into my computer world, into my ArcGIS world, because it gives us a lot of good information. And we need to visualize it in a nice way so we can understand what's going on when we have all these sensors and my whole screen is moving up and down and I don't understand what's going on. So we need to make sure that everything is visualized in a good way so that we can understand what's going on. And because of these trends, I would like to switch over to and dive more into the topic of a digital twin. And I mentioned this earlier. These are some of the challenges which we see today, and many of them are very familiar to you, and we might have had them in the earlier centuries as well. And it affects all different industries. But the thing is, we need to act more quickly, and many more people are involved in solving these challenges. And when we look at the world or at you, right, we hear a lot of stuff that relates to the trends I showed you and to the challenges I showed you, right? You need, tremendous amounts of global changes happening. We need to react to it, right? Massive amounts of new data is coming in because we have all this new technology, and this provides a lot of new data sets which we can use, right? Which you want to use. Interest in simulation, doing the predictions, ML, AI, and real-time, indoor GIS, combining BIM and GIS. Game engines are driving professional expectations, right? All of these things is that this is the demand from you guys we are hearing. And most of the time we talk about, the digital twin, which maybe can solve these things. So we look into GIS that can do the data capture and integration, the real-time and visualization, the analysis and prediction, and share and collaborate. So GIS interconnects and integrates. And this is the baseline of a digital twin as well, right? So that's why we are talking about GIS is the foundation of a digital twin. And when we look at some of the numbers, there was a Gartner survey lately that was looking at the digital twin market, and the digital twin market is forecasted to grow up to a $48 billion industry in just the next couple of years. It says 2026, right? And interestingly, out of the people surveyed or asked, 75% mentioned that they are planning to use a digital twin, right? Which means they are actively planning. So in the near term, they will have something. So they are actively thinking about it. Only 13% said that they are already using a digital twin. And interestingly, and this is why I'm so keen on the system of record thing, only 1/3 said, okay, this fuels only one challenge or one problem. So they are not looking at it holistically, what I'm trying to solve with a 3D system of record. So this 3D system of record is something you build up, and then you solve a problem, but the same data set can then be used in different twins in a holistic twin later on as well. So you're not building up a twin and then it's something that you set aside and then you build up a new twin. No, it's all connected somehow, and we'll come to this later. So maybe when we think about a digital twin, I don't want to do this definition bashing, but just to have a quick recapture what a digital twin is. When we think about a digital twin, what do we mean? Is this just an aspirational marketing term? What can it do? And I think everyone in the room has a different image when he thinks about a digital twin, right? It starts from purely a 3D model towards this highly connected, the video I showed you from Gothenburg, for example. And I think when you think about it, and whenever you have a problem, a question, you go to Google, right? So if you type it into Google, digital twin, IoT, smart city, whatever comes in your mind, what you see is like these city silhouettes with many connections and bubbles, right? So the same is true for IoT, smart cities, whatever you type in. And they are showing connectivity, connecting silos, data communication. So just to rephrase what a digital twin is, right? These are virtual representations of the real world, right? You have a thing in the real world, you copy it in your system. You include the physical object itself, like this jet engine, also the processes and the real-time behavior, how this thing works, how it interconnects with its surrounding pieces and parts, right? And their start was in aeronautical engineering, by connecting a digital representation to the physical world, right? And now they are branching out into healthcare, manufacturing, and more, right? And these digital twins were kind of, incredibly useful for highly engineered systems like these jet engines. But when you think about the built environment, our city-wide scale, then it's not a purely engineered system. The concept of a geospatial city-wide digital twin is relatively a new concept arising from the AEC industry due to the need for high-fidelity models of the project site to make sure assets of a building don't collide with each other. For example, structural steel beams and plumbing. And while this is starting to gain maturity for project site, for a city this means simulating projects in context. For example, how does the entire building project affect shadow cast, wind patterns, and how do new roadways produce noise in the surrounding communities? And you can probably think about many, many more. And they all happen at the same time on a citywide scale, right? It's not just this little complex in itself jet engine. It's the complexity on a whole new scale. And when we look at technology again, I'm always referring back to where we are today. There are three key breakthrough technologies which help to drive this digital twin concept. One is cloud collaboration, right? And many of you have been dealing with 3D since a while, since decades. Importing, exporting, converting, all this stuff, right? And now it's easier to share this information. We have tools and formats to share this information easily, right? We have the streaming file, we have the scene layer, where you can easily stream a whole city across the web and share this out, right? The second one is AI and machine learning in the middle. And this will revolutionize data management and maintenance. Many of you have integrated this technology into your own processes to automate the process of change detection. For example, in this map, this is from the Halo Trust, a nonprofit that is focused on removal of landmines. And then this, of their maps, you see the damaged structures of Mariupol in Ukraine. And based on this, on localized training data sets, they can identify damaged structures across the city, assisting the government in the verification of damage and eventual recovery. It's moving. The car is coming. And the third technology is, again, game engines, right? And this has been out there since a while. But more and more, especially AEC companies, used it to verify their designs with stakeholders, right? Making it realistic, or using game engines to verify how it is built. Think about a roadway stretch, and you do this in a game engine. So you sit in the driver's seat and drive through this whole thing. Then you have rain, you have sun, you have this and that. And then you can simply identify which signals can be seen, which cannot be seen. So game engines help a lot to get stakeholders buy-in and maybe also verify certain situations. And yeah, there's a lot of developer technology that is ongoing, and it's still, I say, a developer technology. We have many tools, especially around urban and city engine, where you can easily plug and play, right? But you need to have some more knowledge using these game engines to make these outputs you would like to have. And maybe over the course of the next years, it becomes easier and more mainstream. But nevertheless, these three technologies are very beneficial and fuel the digital twin concept. And when brought together, right, when all of this stuff comes together, it supports the creation of smart digital realities, digital twins. We call them living digital twins, because our planet is a living thing. We are living, nature is living, everything is moving. So we call them living digital twins. And how we experience the content is changing. It's much richer, more immersive. Like this example here, this is Utrecht in the Netherlands. These experiences are based on a common connected data environment where different objectives can be supported across different industries. And GIS creates digital twins of the natural and built environment and uniquely integrates many types of digital models to power these new experiences. And on the path to a digital twin, our customers are building from their existing approach to how geospatial data is maintained today. Because it's not so much the data itself that is changing, it's how we experience it, maintain it, and work with it. And a modern digital twin allows you to abstract and model everything, bringing together many different information models. And I think you saw this slide in a very different way when we talk about GIS. We bring together many different information models, right? But now we are leveraging it into a 3D aspect to make it more realistic, such as landscapes information models, terrain, topographic, and environmental layers. BIM, or building information models, highly detailed representation of structures and facilities. Then we have the information models for managing networks, such as ArcGIS utility network to manage linear assets and connectivity. And then finally, we have these city information models to support urban planning, simulation, and citizen engagement. And this is really the exciting and unique, to the power of ArcGIS. Location has the capability to interconnect these very detailed models. And apparently, this is the baseline, the foundation to build these digital twins up. Another example here, we are looking at a real-time twin of the offshore wind farm Beatrice in northern Scotland. And this simple web application brings together information about the environment, together with the building information models like this, wind turbine here, what you just saw. Yeah, and it connects it with a network information model showing the relationships between the individual turbines with larger fields, allowing arrows to be traced along these relationships. And location is the ultimate integrator of this unlinkable data. And this is the key benefit of ArcGIS. Right? Everything has a location. We can place it on Earth. We can connect it. We know exactly where it is and how it interconnects with everything else. And ArcGIS has the power to interconnect these digital models and create value by providing a more holistic view. So again, I had this slide before, but when you look at it, when you think about the digital twin, what you just heard and what you have in mind and what you've been dealing with when you talk about digital twin in your past, the ecosystem of ArcGIS provides everything we need. We just need to make sure that it is seen like this, and we provide the right tools and the right applications to support this twinified workflows or these digital twins that our customers would like to have. Right? The infrastructure is there, technology is there. We probably need to think about how we create our tools so that customers jump on it and say, "Hey, this is a digital twin." And to help with that, so when we talk to our customers about digital twin, we think a useful way of looking at it is looking at it like a maturity circle. And in the middle is the 3D system of record, right? This is your essential piece which fuels everything. And when you look at the digital twin, a digital twin is something, not something special. A digital twin is like a hammer, right? Or a screwdriver. It's a tool, and it solves a problem. So in this case, you have the system of record. And how do you fuel the system of record? You do the data capturing, reality capturing, creating depictions of the world, bring in BIM data, bring in reality capture data, bring in all this kind of data to fill your system of record. And then it goes into the second step, right? Taking this information into the geospatial cloud, which we refer to as the ArcGIS system, leveraging configurable components for visualization, simulation, analysis, and more, right? And then the next step could be that we have the benefit of open data and providing access through APIs. Number 4, real-time is facilitated by IoT sensors and indoor positioning systems, which can be displayed in real time, or today near real time. And then finally, it's not hard to realize that all of these steps so far must have in purpose a use case, which are our applications and solutions, right? And this is what we operationalize as digital twins. So it's like a maturity step. So there are many, many steps towards a digital twin. And you can start off by using this kind of maturity and encounter to build up a twin for a certain use case. I think yesterday I visited Vilnius Plana, and they, maybe you should talk to them, because it's not so much about what they do, but how they did it, right? They have an issue to solve. And what they do is they start off creating this system of record, having in mind that this system of record can also be helpful for something else. So building up these different twins on various locations, because this is an urgent pressing need they need to build up. At the end of the day, they may come to the conclusion and have this holistic twin for Vilnius. And I found this pretty interesting, because many people come to us and say, "Hey, I need a digital twin." And they say, "Okay, well, okay, for what?" Because, right? So, good. Maybe we should sit down and talk about the problem you want to solve, right? And then we have so many tools, right? You have Urban, Pro, this and that, and GeoBIM. Everything is part in this whole encounter of creating a digital twin. And it solves a problem. And a smart city on top of it is only the concept, right? To be a smart city. And the smart city uses different tools to become a smart city. One is probably having a web page where you can go in and apply for a new passport. Awesome. Another tool is a digital twin for doing this and this and this. So this is a tool, and technology, can help you to solve this. And when you type over it, at the end of the day, this is a digital twin for my planning scenario, then it is a digital twin for your planning scenario. One thing I want to emphasize, this is something you have seen already, the system of record. For me, this is the initial piece, because the system of record is not only that you have the data in there and you store them there, it's a system of record, but it's also, when you think about a digital twin, right, the first step, you create this twin. You create the replica of the world. You connect it to the world, right? So it runs. And maybe the highest step of becoming a twin is the autonomous twin that can really do stuff, because it learned from the outside world and know exactly what to do in case of, right? So these are the 3 steps for a digital twin. And the system of record is actually the keeper of all of those. So we create assets, right? We connect data, and we also store the transaction that are related to the data. And out of this, we can do the system of insights, we can do the system of engagement, and then the digital twins really comes to life. So again, system of record, keep that in mind. And once you have this, I would say the system of record, like the reality capture and data integration piece in place, as I mentioned before, right? You have a problem maybe here in the operations sector or in the design and construction sector or in the planning sector. Start, going that path and create like a planning twin. Start with that. And then other solutions might come up next because you learned how to build this one up, then you can go into the design construction twin and build this one up. And all that's based on the system of record. And then they interconnect with each other. And then on top of it, you may have this digital twin solution for your city, for your community, or maybe for your country. But the outcome-driven approach is always looking at the certain problem and start from there. But keep the system of record in mind. That might be helpful for other twins as well. Starting top-down is probably tough to say, hey, I would like to build up a digital twin for the city of Vilnius. Then maybe that purpose is not really there, and it's tough to actually start working on it. Here you can see an example of Vienna's high-detailed 3D mesh. It's just another video I wanted to show you, and this can be used together with your existing GIS data. You have seen a lot of images and videos so far, but it's pretty easy to do so, right? Your 2D data is still valid for it, also for a digital twin. Just combine this information. This is again the city of Utrecht, which I showed you earlier, where you have this 2D information and create just floor levels out of it. And just, use a mesh, the underlying mesh, right? You visually see that this is a building, right? The computer does not know that this is a building. But the vector data underneath can fill it up, and so you get the attribution, the knowledge about this certain building in, and easily can communicate around it. I don't know what's here by the time. Okay, so actually, this is more or less my last slide again to emphasize on what I've been talking about. The smart city is maybe a concept, right? And you will have different concepts where you need to introduce digital innovations. And one of those digital innovations can be a digital twin, that create these virtual representations of the real world, including physical objects, processes, relationships, and behaviors, right? And ArcGIS, hopefully this came through my presentation a little bit, that ArcGIS is really, the one that creates those digital twins of the social, natural, and built environment, and uniquely integrates and interconnects many types of digital models. It can combine those things, right? You can connect to all those sensors, you can do this analytic stuff. The only thing that we need to work on is the interactiveness. So you create this model and you can interactively work across this digital twin to solve those problems. And what ArcGIS does is that no other technology can do is integrating and connecting all these different types of digital models across information models with location as a key to building relationships. And I think this is the most important thing. Yeah, a digital twin is not a representation of 3D something. A 3D model is a representation of 3D something with its relationship to its surrounding world. Only this is a digital twin, and that can help us to simulate and then predict and make decisions. I think this is all I wanted to say today. Thank you for your participation. And if you have, one more thing. one step deeper, because this is really stuff I'm working on, the 3D across ArcGIS, because this one is really helping driving this digital twin effort. And this is what I'm working on with my team. We're looking at the content, which is purely the system of record, right? Looking into data editing, content formats, and data creation, and all this stuff that fuels the system of record. And then looking at the visualization, the stylization, how you present 3D information. And when you think about 3D information, and I probably haven't touched on it in this presentation, but 3D does not mean we represent the city of Vilnius in 3D in the web. This is one part, but we can also view statistical information on the web in 3D, right? Which can also be very complex, but we can use 3D techniques to actually create those 3D maps and show them nicely. Analysis, right? Deep learning, point cloud classification, service analysis, volumetric and proximity analysis. All this stuff based on 3D is something we are looking at, which helps at the end of the day at the digital twin. And then the immersive experience. And the immersive experience is not only the XR workflows, AR, VR, the goggles and all this stuff, but it's also how we present this 3D content in our 3D web applications. Think about the scene viewer, right? Experience builder, story maps, dashboards. This is also an experience, and if we do it right, information will be received in a very, very good way, and seamless collaboration with other tools helps to understand the problem. And I wanted to emphasize this because this is what I'm working on at Esri, and I'm leading it. So I want to create it as an integrated piece. And interestingly, when I joined Esri last year, there was no real story about 3D. 3D was always this kind of thing we can also do. So last time when I talked to Jack about this one, I presented him like the story, and we can talk about the story tomorrow in our technical session. And he said, hey, this is a story I can understand, right? And thinking about why we are doing 3D, and I hope I presented this a little bit, a digital twin can be the highest goal to reach for dealing with 3D. And whenever we work on those different pillars, we think about, okay, what can it be in the digital twin? And hopefully then it's the right way. And then maybe just having a what's next slide for the Esri technologies. I mean, there's so much stuff on here. I can read through it, but I think the AI stuff is interesting. Another aspect which I want to mention is the GDP stuff. Everyone is maybe using GDP for testing, maybe getting scared. I don't know. But this is a huge potential. I don't know where exactly it will lead to, but it is an interesting concept, and it will revolutionize a lot of things. And I think that's it. Thank you.